Okay, 3.4, that is the fourth section of the third chapter. First, I'm just going to generally talk about how to use direct truth tables to check an argument for validity. Here I have at the top a 4-row truth table as we discussed before with the 4 cases. First case where P and Q are both true, reading across horizontally. Second case where P is true and Q is false, reads across horizontally. Third case, P is false, Q is true, and so on. We get the last case here too, P and Q both false. Now, hopefully, and really to do this section, you need to know how to do calculations in a table. We're going to have some formula up here, okay, just, for example, I'm going to erase this in a second. Let's say it's P or not Q, okay? And then you calculate in the 4 different cases. If it were this, for example, let's go ahead and leave that as an example here, actually. We're going to have true or false in this case, which is true. In this case, I'm going to have true or true, which is true. And it might take you longer to calculate these, but stop it if you're not sure or go back and check. In the next case, it's going to be false. I have neither P nor not Q. In this case, in virtue of not Q being true, the claim is going to be true. Okay? We could do this for the second, third premise and the conclusion of any given argument. We need at least one premise in an argument, but there's no particular number that we need to have. Okay, so the question here is how we can use a table once we calculate the truth values of all premises, however many there are in the conclusion, to tell if an argument's valid or not. It'd be a good idea to stop and pause here and think for a second. How would the table tell? Remember that what this table does is it considers every logically possible scenario in terms of our base sentence letters or variables P and Q. So we've covered every possibility. Now, you need to ask yourself what a valid argument is here. And if you don't know, maybe pause this and see if you can think of it. Well, the answer is that a valid argument is one in which it's impossible for the premises to be true and the conclusion false. Put it another way, if the premises are true, the conclusion has to be true. All right, so what we do here is look at all the cases, and again, you can pause here. What are we looking for in terms of thinking about whether or not the argument's valid? Again, pause it if you like. The answer is we're looking for a case where all the premises are true and the conclusion's false. And that's what we look for in these particular tables. So in other words, if I just sketch in some truth values here, let's say I go false, false, true, false, and I say false, true, true, true. Okay, that would be determined by whatever the second premise was, okay, in the particular argument we have. And for the conclusion, let's say it goes false, false, false. Make that a little better, true. Okay, now, the question is it possible, is there ever a case where the premises are true and the conclusion is false? Well, in case 1, we have first premise true, but neither the second nor the third premise is true. So that is not a case with all true premises and a false conclusion. Case 2 is you read across here. We get stopped at the second premise. It's false. Case 3, the first premise isn't even true to begin with, so that does not give us all true premises and a false conclusion. Case 4, we do not have a true second premise, and the conclusion is also true, both of which would block it. So as it stands, this argument, pictured here with these truth values, would be valid. So I ask you, what could you do to, what truth value change would give us an invalid argument? Pause, think about that. What's a single thing that could be changed here so that our determination would be that the argument's invalid? You can pause and think about that if you didn't already do it. And the answer is right here in case 2, we could change this false to a true. Then we would have true, 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 false. First 3 things being for the premises and false for the conclusion. And another single maneuver that we could make in case 3, if we change the first premise to true, that would then give us a proof of invalidity. Then we would have all three premises true and the conclusion false. Okay, so that's the basic idea. The same thing would go in the case below. We would have 8 different cases if we had 3 different sentence letters, P, Q, and R. And but again, what you're looking for, what shows invalidity, is where all the premises are true and the conclusion false. I'm going to say one more thing here. Let's pretend, for the purpose of illustration, that as a matter of fact, in case 3, it turns out that the first premise is true. Okay, so let's sketch that on here. Let's go ahead and make a quick modification to illustrate that. Let's say that instead of being P or not Q, well, we need a tautology based on the way this thing is sketched right here. So we'll make it P or not P. There we go. All right, so now what we would do, the way I want you to specify it and the way that ultimately you'll be tested on this, is that we will point to case 3 where all the premises are true and the conclusion is false. Sorry about that, bad T, but this is true right here. And then specify the truth values that makes all the premises true and the conclusion false. We just have 2 truth values, P as false right here, Q as true. That gives you all true premises and a false conclusion. So the way we would state this, the way the exercises go in the text, say invalid, let P be false and Q be true, because that's what we have in the third row, third case, and that gives us all true premises and a false conclusion.